next and solve those inequalities. We write our solutions in interval notation, and then we graph them on the number lines. Okay, so remember that solutions to the inequalities are all of the values of the variable that make the statement true. So how many solutions are there? An infinite amount. You can put all kinds of numbers in there to make them true, make that true, okay? So someone else, Mark Sparks, for example, solved this inequality, just like that, those steps over there, and found a solution that x is greater than or equal to -1. So your solution in interval notation would be a -1 with a bracket up to infinity. And it says graph this solution on the number line. So go ahead and graph that. Open circle at -1, and everything to the right of that. Yes. Good call. Thank you. Okay, so choose a value from the solution interval and substitute that into your original inequality. So what's a really easy number to plug in?
2.
Okay, 2 or 1, you can do both of those. I would have chosen 0, but I can do whatever. Okay, so whichever one you want to plug in, go ahead and plug it in, as long as it is greater than or equal to -1.
In fact.
Yep, plug it in for x into that original equation right here. The 3, you can see the original one. What happened? Did you get something that wasn't true? Yeah? Why? Okay, you get something that's not true. So whatever number you picked, hopefully when you did your math correctly, you got a statement that was not true. Whatever number you got was not less than or equal to or greater than or equal to the other one, right?
So Mark Sparks got it
So
wrong.
Mark Sparks got it wrong,
Boom.
right? But do you know why he did it wrong? What did he do wrong? Yep. So right here, in this step, from here to here, what did he do? What math did he do? Division by a -2, right? When you divide by a negative, you gotta flip the sign. So when you divide by negative, you must flip the inequality. You don't have to write it right here because you're gonna write it on the next page. So just, you can put like hidden flip the inequality or whatever you want to put there. Because as a reminder, an important rule when you're solving inequalities, when you multiply or divide both sides of the equation by a negative number, you have to flip the inequality symbol. Then again, you get to solve some inequalities and write the solutions in interval notation. Here are the answers to the first one, if you want to check that. And the answers to the second one. Finished with these two, you got them correct, you go ahead and mark those next two. Okay, so it looks like most of you solved them correctly. But then when you go to do your interval notation, this means that x is gonna be between -2 and +5. So it's anything between those two numbers. So it's not gonna have a union. Remember that union means or. Same on this one. Everything between -2 and +3. So that one will not have a union either. Remember with interval notation, you always go least to greatest. So even though right here we got that 3 was greater than or equal to x greater than -2, you have to flip it and put it in interval notation. So that goes least to greatest. So do you remember when the variables completely canceled out of an equation? Hopefully you do. For example, you end up with a statement of 0 equals 0, which meant there were an infinite number of solutions. Or you end up with 0 equals something that's not 0, like a, where a is an real number, which meant there was no solution. So let's see if the same thing holds true when solving inequalities. So here's two more. Solve an inequality and then tell when the result will be true. There were any answers. Okay, is 0 greater than negative 5? Won't that always be true? Yep. And on the second one, hopefully you got 0 is greater than 11. Is that true? No, will that ever be true? Nope, so that one's never true. Okay, so if your answer, your resulting inequality is always true, then your solution is any number between negative infinity and positive infinity. If the resulting inequality is not always true, then there is no solution to the inequality, or never true. For it to be mathematically true, it must be always true. A little star right there. So we have compound inequalities. It's probably been a minute since you've seen these. So compound inequalities are inequalities in which there are two or more conditions on a variable. So there's two different kinds, and mine looks a little bit different than the one on your paper. Yours is like stacked on top of each other, but when I tried to like put it in the slide like that, it looked really strange and really small. So mine's a little bit different than yours. On the number line, graph each inequality separately and label which is which. So on the first one, we have x is greater than negative 2. So that's going to be an open circle at negative 2 pointing to the right. Other one is less than or equal to 3. It's going to be a closed circle at 3 and pointing to the left. So this part is underneath on yours. Since the conjunction word is and, the solution is all the values of x that are common to both inequalities. So it has to be true for both of them. So what part do these two lines have in common? Between negative 2 and 3, right? So everything's starting at negative 2 with an open circle, up to 3 with a closed circle. That's what they have in common, what they share. So if you write it like an inequality, it's negative 2 less than x less than or equal to 3. And Interval notation, it's gonna go from -2 with a parenthesis, comma 3 with a bracket. Alright, now we're gonna do an or, so you're gonna do the same thing. Graph each inequality separately, label which is which, and figure out. Why is this one a little bit weird? They're both pointing to the left, right? They're going in the same direction. Now this one says the conjunction word is or, which means it can satisfy either one of these. So on the number line, graph the solution interval that contains a solution to either one of them. Yes.
On your little graph thing, it's on one number.
And just pretend I'm gonna do it. Thank you. That's twice. Oops. Okay. So if it makes either one true, what is this gonna look like over here?
Run through
It's gonna go through the -1, so it's gonna be just like that x less than 3. Because that one encompasses both of them, right? It's really weary hitting the next button, because I'm not sure it's gonna be right now.
one page.
I know it. You're gonna get some homework out of him today. Okay, so and has to make them both true, or can make either one true. So these say solve the compound inequalities and write your final solutions in interval notation. Okay, so we'll solve the first one together. There's a lot of number lines. So what's the first thing I'm gonna do? Distribute. 3 times 2 is 6. 3 times -x is -3x. Yeah, 6 minus 3x plus 1 greater than x. Combine your like terms. -3x plus 7 greater than x plus 3. You add your 3x over, subtract 3. 4 is greater than 4x. Divide both sides by 4. You'll get 1 is greater than x, or x is less than 1. Second inequality, distribute the 2, you get 2x minus 6 less than 4. Add 6 to both sides, you get 2x less than 10. You should get x is less than 5. And what word do we have in the middle this time? And, so we have to make both of these inequalities true. Our first one, x is less than 1. The other one is x is less than 5. So what kind of solution makes both of those true? Can you have a number like 2? Does 2 make both of them true? No, it only makes the bottom one true, right? Since it's an and in the middle, it has to make both true. It's gonna be that x is less than 1. Because x is less than 1 makes both of them true. And so this is all of those. If it were a 4, 2 would work. Since it's an and, it does not. And go ahead and work that next one. I won't interrupt you this time. Okay, hopefully this time you got that x is less than 5 or x is greater than -2. Okay, so what kind of numbers make that true? All numbers. So anything between -infinity and +infinity. Okay, go ahead and do the next 2. Or the last 2, I should say.
last on this info.
Could it?
Never mind.
Good catch. I did not notice that. So hopefully yours looks like mine. You get x is greater than or equal to -1, and x is less than -3. Okay, so what kind of numbers make both of those true? There's not any, right? There's not one that's less than -3 and greater than or equal to -1, so there's no solution. I can recognize that, I just breaking in while I work. Typing all this in. Okay, so on the second one, you solve it the same way, greater than or equal to -1, or less than or equal to, or less than -3, sorry. So in this case, it's either one, right? So it's all of those things up to -3, and then everything from -1 up. Because it can make either one true. So this time you do have everything in. Okay, so at the end of the notes, all we have left from Unit 1 is the green day 6 homework and free response 7 and 8. Okay, so next class period is your test. Monday, September 14th is your test, okay? So you just had a quiz, so you kind of know how well you know the first 4 lessons, right? And then you're gonna have a test which will include those first 4 plus interval notation plus what we did today. Now, I'm not gonna make you turn in homework to me on the day of the test because then I can't grade it and give you any feedback before you take the test. So this homework, right here in front of you, I'm gonna post the answers. Actually, what I'm gonna do is I'm gonna post the answers to all of the homework from the unit. So I'm not gonna collect these 2 pages from you when you come back on Monday, right? Your review is all the stuff we've done so far. You're gonna need to know that chart we did on the first day with the different kinds of numbers. What did we do on day 2? I don't remember, let me pull all this out. Talk through it real quick. Okay, so we did the complex number system, all those different types of numbers. We talked about all the different properties, reflexive, symmetric, transitive, associative, all of those fun things. We talked about multiple choice and free response. On day 3, day 4, we talked about application problems with those charts. You had to fill in distance equals rate times time. And then those few geometry problems we had. We talked about consecutive integers, odd integers, and even integers. You remember those things? We had some free response. Day 5 was interval notation. Today we did day 6. And then day 7 was just these last 2 free response questions. Okay? So your review is all the stuff you've got. And I feel like you'll be well prepared. Like I'm not worried about it for you. There is one thing I want to show you before I can find my mouse. The green day 6 homework has a typo in number 9. There's a random A when there should be an X. So what I would recommend is we still have 20 minutes till lunch and then 20 minutes when we come back from lunch. So I would go ahead if I were you and work this green one, day 6 homework, get your practice in, and then you can come and check it with mine. I mean, I'm gonna post the answers at some point. But then you can also do the free response, and then you'll have all of the rest of the time to study all of your notes and all of those things, okay? Questions about your test on Monday? Yes.
So we don't have another, like, 9, 5 free response section or?
Yes, the test has, I don't remember how many multiple choice. Let me look. Oh, I know where it is. So there's a calculator part and a non-calculator part. I will have my calculators ready for y'all to use by then. And I also think most of your classmates get to come back that day, so
Let's go.
yeah. It'll be like having everybody together. Okay, there are 7 calculator and 7 non-calculator. So 14 multiple choice and 2 free response. 1 with a calculator, 1 without a calculator, 7 with a calculator, 7 not without a calculator, or not with a calculator for your test. Yes,
Can you get quarantined twice?
yes. So like when everybody comes back, if they sit next to somebody that tests positive, they could be quarantined. So much fun. That would be the worst.